you can always actually fix the value of x into the function to know whether you're actually right, okay? So over here we have x to be equal to this 2.5. So if you should fix the value of x over here into the function, into something like, it will be something like 16 exponent 2.5 minus 1. So when you fix this into your calculator, you're supposed to get 64. If you do not get 64, what it means is that your answer you had here for x is actually wrong. Okay? So these are ways that we can use to find out and know whether the values of x you have are actually correct. So we would want to consider about 3 or 4 more examples. Then from there we'll say bye-bye to indices, and then we take a look at logarithm. Okay, so let's see another example on this. Okay, so 3 exponent n plus 1 times 9 exponent n divided by. Okay, so let's try this question. So we have 3 exponent n plus 1 times 9 exponent n divided by 27 exponent 2 n on 3. Okay. Okay, so the idea is that we have to write 27 in base 3, or we have to find a common base for all of them, okay? So we have to find a common base for 27, and so 27 is going to share that same base with 9, and 3 is also going to share that same base. From here we can see that the simplest base we can get for them all is 3. Okay, so we are going to write 9 in base 3, we also write 27 in base 3. So it's going to be 3 exponent n plus 1 times 9 is the same as 3 squared, okay? So 3 squared. And then n is already there as an exponent. Divided by 27 is the same as 3 exponent 3, then times 2 over 3n, okay? 2 over 3n. Okay, so let's move on. So we are going to get n plus 1 times 3 exponent 2n. So this 3 over here is actually going to cancel this 3 here. So we have 3 exponent 2n. The reason why it is 2n is because this 3 cancels this 3. So we have 1 times 2n, which is actually 2n. Okay, so I think from here we can clearly see that we can apply indices from here. Okay, so we'll just apply indices. We pick one of the bases as indices says. Where they are multiplying, we'll add. Where they are dividing, we'll subtract, as indices taught us. So it's going to be n plus 1 plus 2n. Okay, so plus 2n. Since it's dividing over here, it's going to be minus 2n. Okay, so this is going to be equal to 3 exponent 2n minus 2n is 0. So it will be 3 exponent n plus 1. Now, this is also the same as 3 exponent n times 3 exponent 1. Because you remember that whenever they are multiplying, you write one of the bases and then you add the exponents, right? Okay, so this is also the same as 3 times 3 exponent n. So this is actually going to be our answer for this question. We can choose to stop here, or we can choose to stop here. Either way around means the same thing, okay? Okay, that's good, that's good. So let's take the next question after this. Let's consider number 2. Okay, let's consider number 2. Okay, so we have x plus 6y to be equal to 3, 2 exponent x plus y to be equal to 1 over 4. So this is actually simultaneous equation. You can call this equation 1, call this equation 2. Okay, so we can see that the number 1 doesn't really have any issue, but then the actual problem is with the number 2, which is in the form of indices. So we'll have to convert the number 2 from the second equation from indices to the normal way we know the quadratic, the simultaneous equations to be, then we continue our solution. So let's solve this and see what we are going to do. So we are going to begin by converting the second equation from indices to the normal form, okay? So let's consider the second one. So this is x plus y equal 1 over 4. So we have to write this whole thing in base 2, okay, because we have a base of 2 here, which can be broken down anyway. So we have to also find a way to be able to write 1/4 in base 2. So let's see how we are going to do that. To be equal to 1/4 is the same as 2 squared, okay? 4 is the same as 2 squared, and then x plus y equal, from indices, we learned that this is the same as 2 exponent -2, right? And since we see that the base over here is the same as the base over here, since the bases are the same, it means that the exponents are as well the same. So we can write x plus y equal -2. So x plus y is the exponent on the left hand side, and then it should be equal to the exponent on the right hand side. Okay, we can call this one equation 3. Then we'll have to solve them simultaneously. So solve equation 1 and 3 simultaneously. So all we are going to do is that we are going to solve equation 1 and then equation 3 simultaneously. Don't forget that equation 3 actually it came from equation 2. Okay? Look, so I'm going to play this one. Then we'll continue our solution from this side. Okay, so let me rewrite equation 1 and 3. So 6y equal 3, then x plus y equal -2. This equation 1 and this equation 3. So there are so many ways that we can solve this simultaneous equation. There are so many ways. One of the easiest ways is by subtracting, okay? We can actually subtract equation 3 from 2. Okay, this is equation 1. Okay, so we can actually subtract equation 3 from equation 1. Okay, so let's see how that's going to be. Equation 3 has x, so we subtract this x from this, so going to be x minus x, then plus y in equation 3, minus 6y here. That will be equal to -2 in equation 3, then -3. Okay, x minus x is 0. Okay, y minus 6y is -5y. This also equal to -5. Y is going to be equal to -5 over -5, which is going to be equal to 1. So y is equal to 1. After we have y being equal to 1, we have to go and solve for the value of x. That's the corresponding value of x. We can actually fix the value for y into either equation 1 or equation 3. Either of them will give us the same answer. So if I were to be the one, I would have chosen to put it in equation 3. Okay? So let me write equation 3. So put y equal 1 into equation 3. So we are going to fix this y value into equation 3. Okay? Okay, so let's rewrite equation 3. X plus y equal -2. So x plus the y is 1, so 1 equal -2. So x is going to be equal to -2 minus 1, which is -3. So x is equal to -3. So the answers for this simultaneous equation we have are x is equal to 1. Sorry, okay, x is equal to -3. X is equal to -3. And then y is equal to 1. So these are the answers we have for our question. And for you to know whether the answer you have is correct, you can just fix the values of x and y into the equation here. So if you fix x equal -3 here, and then you fix y equal 1. Y equal 1 means it's going to be 6 times 1. So -3 plus 6 is equal to 3. That's what we look at. If that's the case, then it means we are right. If that's not the case, it means our answers are wrong. Okay? And we see that that's actually the case over here. What that means is that the answers we have for the equation are correct. Okay? So this is one example on indices. Okay? Okay, let's consider another question on this. So you can choose to pause the video over here, and then you write this down, then we continue. Okay. So let's take another question. We are going to consider another question on indices. Because of time, we are not going to solve a lot of questions anyway. So we'll pick question under a different sector. This is 2 exponent 2x plus 1 minus 9, 2 exponent x plus 4 equals 0. This is another type of indices question which we can solve. It's so easy. Don't worry. So easy, okay? Don't worry. Okay, so let's see how we are going to do this. So in order to solve a question like this, what you have to do is that you have to find a common term that is running through. Okay, you have to try and find a common term running through. From here, I can see 2x over here. And over here, I can also see 2, and I can see some x here. So can I try to generate 2x out of this side? If I'm able to generate 2x from here, then it means that I'll be able to solve the question easily. So let's see how we are going to do that. So this is the same as 2x times 2, right? 2 exponent x plus 1, 2 exponent 2x plus 1 is the same as 2 exponent 2x times 2. Okay, because this 2 has an exponent of 1, and then we said that whenever the bases are multiplying, whenever we are multiplying the numbers, we can add 2x to 1. So 2x plus 1 will give us this. So it means that this is actually the case. So 2 exponent 2x times 2 minus 9, 2 exponent x plus 4 equals 0. Now, can we get 2 exponent x from here? Yes, we can do that. So let's see how we are going to do that. Let me write this 2 first. 2, and then over here, I'm going to write it like this. 2 exponent x, then I write this 2 outside. Okay, outside the brackets. Because after all, we studied from indices that this x can multiply this 2 for us to get a 2x from here. Okay, so minus 9, 2 exponent x plus 4 equals 0. Now we can see that we have the term 2 exponent x running through. So we can easily replace 2 exponent x by any form of a variable. So let's replace 2 exponent x by any variable. So let's say n, let n equal 2 exponent x. So if n is equal to 2 exponent x, we are going to replace n here inside the equation. So we are going to get 2, wherever you see 2 exponent x, we replace n. We replace with n. So we are going to get 2m squared minus 9m plus 4 equals 0. So we now have a quadratic equation. Okay, there are so many ways we can solve the quadratic equation. So many ways. So let's use the basic way that we know from JHS, from junior high school. So the basic way, what we do is that we compare this to the general form of all quadratic equations. The general form of quadratic equations are ax squared plus bx plus c equals 0. Now we will find the a and then the c. So from here we have a to be equal to 2, and then we have c to be equal to 4. So what you do is that you multiply a by c, a times c, and a times c is going to give us 2 times 4, which is 8. Okay, so now we tend to find the positive and negative factors of 8. We are going to find the positive and negative factors of 8. That's plus or minus 1 is a factor of 8, plus or minus 2 is another factor of 8, plus or minus 4, that's another factor of 8, and 8 itself is a factor of itself. Okay, so there are 4 factors, or we can say 8. We will consider the positive and negative factors. So what we are going to do is that these factors we have, we will consider 2 of them. When we add them, we should get negative 9. We should get a b here. But when we multiply them, we should get a times c. Okay, so the 2 factors we have, when we add them, we should get negative 9. But when we multiply them, we should get 8. And then from here, we can see that if we pick negative 1, then negative 8. So we pick negative 1 from here, pick negative 8. We see that when we add negative 1 to negative 8, we get negative 9, which is here. And also when we multiply negative 1 by negative 8, we get 8, which is a times c. Meaning the numbers we are actually going to use in solving our question are going to be negative 1 and then negative 8. Okay? Okay, so you can choose to pause the video and write this side. I want to play this thing and then we continue with our question. Okay. Okay, so we are going to use negative 1 and negative 8. So we are going to get 2m squared minus m. 1m is the same as m. We are going to fix the negative 1 and negative 8 here. So minus 8m plus 4 equals 0. Then we factorize this side. We also factorize this side. So When we factorize this side, we can factorize m out to get 2m minus 1. Here it's also going to be minus 4. 4 divide 8 twice, 2m minus 1. Okay, for 0. Okay, we are good. So let's move on. So we also factorize 2m minus 1 out for 0. So now we are going to solve this. So m minus 4 equals 0. M is equal to 4, positive 4. Also, let's come here. So 2m minus 1 equals 0. 2m equals 1. M equals half. Okay, so we have two values of m. But don't forget, the question didn't say we should find the value of m. The question said find the value of x. So we'll go back to this side. Then we look at the relationship between m and x. So when m was 2, so you tell them that m is equal to 2 exponent x. So when m is equal to 1, what is the value of x? So when m equals 1, we replace m here with 1. So we are going to get 1 to be equal to 2 exponent x. Now we try to write 1 in base 2. 1 in base 2